Hi, this is the Norman Tool Motion Pro single axis actuator, or single axis tester. It has a single actuator. This is our, I would say our standard actuator now. It's 1,000 gram capacity. The accuracy is anywhere from probably 150 grams and up. Once you get that under 100, it's not quite as accurate, but we're testing out a smaller actuator for the lower loads, for high accuracy at the lower loads, and a larger actuator for up to 5,000 grams or maybe more than that. So, and this is our standard fixture. I've got a scale sitting there for this demonstration. And this is the control box that comes with it. They are not attached, they're just attached by some cables that you connect, so you can kind of move them around as you need. So this, we'll start with the main screen here. I'm going to show you a demonstration of everything that's on here. First thing you need to do is reset actuator alarm. And then you go to navigation. Here's our main navigation page. So it has a startup section, a testing setup section, and general settings. Startup, first thing you need to do is go to the manual motions. I'll try to hold my phone here. You hit save Z settings, and it sends all the data to the controller for that actuator. And then you hit phase, and it does a little jumping up and down. Then I'm going to reference it. And when it references, it moves up to the highest position, and then it backs off a little bit. And before I hit that reference button, I did hit that motor on to turn the motor on. So, and you can turn the motor on and off. When you turn the motor off, it just drops down. Then you can turn it back on and tell it to go back to position 0, and it'll go to position 0, which is back at that home position. So from here you can jog positive and negative just by pressing the button. It moves up and down, and it shows you the position that it is from that 0 position. Go back to 0, that goes to 0. Now, so you can tell it what position to go to. You can tell it to go to 15 millimeters, and then move to that position. It's going to move down to that 15 millimeters. I punch in 0 and hit move to position. It's going to go back to that 0. So that you can control that, and you can tell how the force to press to. I'm going to turn the scale on here, put that underneath there, make sure that's on grams, and I want to tell it to go to 300 grams. Press to force, it's going to go down and press. Whoops, I have to hold that button on the side. So 306, it's a couple percent high, and we'll go through a calibration procedure as well, just to make sure everything's calibrated. I'm moving back to position 0. So that's the manual screen, the manual motions. The calibration, this is very easy to do. It sounds complex at first, but it's not. There's a calibration procedure that you can follow. But I'm just going to tell you it right here. Basically, you want to calibrate at the low end capacity of the actuator and the high end. So there's a couple numbers that we want to talk about. Try to get the glare off of there. The actuator, the low end value is 200, the high end is 8,000, and those numbers don't mean much to us, but the controller it does. The stuff that means something to us is the actual load. So the box 2 and box 4, 154,093. That's the actual grams that we've determined matches those values. So to calibrate, we're going to start at 200, and we're going to say, hey, let's press at 200, and you tell me, or I will tell you. I'm going to press this button here, press to 200, and so when we press to 200, we actually see 156. So I'm going to move that position back to 0 so it's not pressing on my guy there. So when we press at 200, we saw a value of 156. So the controller, his value is 200, our value is 156. At 8,000, I know that's just at the high end capacity. That should be around that 1,000 or above. So at 8,000, I'm going to press 1,095. That's what this value is. I'm going to put 1,095. That's what we saw. Not much different than what we had before. So now we have it calibrated. I'm going to put this back to 0 position so that's not pressing. we have it calibrated, but we don't really know that because we haven't tested it. So I'm going to say, let's go to a target force of our low end of, let's say 200. That's towards the low end. We could do 150, we'll run to, and I'm going to press that force. I'm going to hold this button in, press the force. It's at 202. We're 201. We're, what, 0.5%? Is that 0.5%? Yeah. So that's very close, very accurate. And then at the high end, somewhere around the high end, 1,000 grams. I'm going to press to that. I'm pressing the button now. We're right at 1,000. So we just calibrated this. Move back to position 0. So within, I don't know, a couple of minutes, we calibrated at the low end and the high end, and we tested the high and low end. And just to be sure, see, we were actually testing, going to do a test at 600 grams. Put 600 grams in there to see. I'm sorry about my video quality, it's terrible, but press to the 600 grams, and it's right at 600 grams. So if we were doing a test at 600 grams, I would feel very confident, move it back to 0, that we are where we need to be. Very accurate. I mean, most test parameters are happy if they're within 10%, or 5%. Okay, so that's so we talked about the manual motions, the Z-force. Let's just get the settings out of the way, because that's something we really don't mess with, but they exist. The fast and slow speed of those manual moves. There's other parameters in here. I won't get into any of this stuff. Accelerations on the vertical axis. Don't really need to mess with that much. Advanced setup. Excuse me. So these are all the settings, all the numbers required to make that actuator move properly. So they're set by us. You don't need to change them, but if for some reason something wasn't working right and you call us up, we may need to have you change some of those. When you will need to change these is if you take this actuator off and you put the lower capacity or the higher capacity actuator on. These numbers will have to change, and we will tell you what they need to be. But we put them here so that we don't have to come out and do that for you. You can just email us and we'll let you know what it needs to be. Testing, that's the only thing we have left. Let's go to File, Import, and Export. So we will create a series of steps when we do a test, sometimes maybe just one step, one operation, and we define certain parameters. So you want to save those as your test parameters. So we want to export them to a USB file, our USB drive that we will put in here. When you're ready, after you're done doing a test, generate that steps file, export it to a USB drive. And then as it's running a test, it generates, it populates all the data as far as the maximum velocities and different statistics. Generate that statistics file after you run a test, export that to the USB. So it'll create spreadsheets, some CSV files for those, and you can export both of those, and then you can come back at a later date, so you don't have to punch that information in for all those steps. You can generate a file from that USB and then import those steps. That's all that this has to do with is the file import export. So steps editor, this is where you actually create the steps. You have to edit the steps, hit that button, and this is carried over from our 2 and 3 axis tester. So there's 100 steps in here. You probably will never use anywhere near that, and possibly not even on those other ones, but we left them in here. If you're just pressing to a force and lifting, you'll really need just one step. If you're pressing to a position, maybe to move a different position and back, then you'll need multiple steps. And when you do, just define all of them as 0 until you get to the last one, and then define the last step as a 1. So when it sees a 1, it'll ignore everything else past that. So we're just doing one step here. The press type 1 is press to a force. Press type 2 is to press to a position. So we're pressing to a force. Vertical speed is millimeters per second in the downward direction, the pressing direction. Target vertical, press type 1, that is grams. So we have set this to 300 grams. If you're press type 2 to a position, this will be in millimeters. So maybe 10 millimeters or 20 or something like that. I/O argument, we do have an input port right here. You can hook up a, I think this is the M3 cable, I believe. So we have, actually I don't remember what that is, M8 I believe. I'm thinking 3 because there's 3 wires. But anyway, there's 2 wires, the blue and the brown I believe, that you connect to your switch. And then as this test, every time it presses, it'll check continuity. And it'll count. It can count each time it presses. If it passes, if it sees continuity, it'll count that as a pass. If it doesn't, and it doesn't increment the pass count. So the IO argument 1 means yes, we're going to detect an input. 0 means just totally ignore it. We don't care. Lift at the end. We'll probably take that off of this screen. We're not done with the final development of this, but that's left over from the 2 and 3 axis where you may not want to lift and move to the next position while you're still pressing to create a slide. So we'll probably take that off of this because we'll always want to lift. Dwell time, that's how long to continue pressing before you lift. Repeats, so if you have more than one operation, you can repeat each operation a different number of times before it goes to the next one. And then once it completes all the operations that's defined, it'll count that as one cycle on the main counter. Then we talked about the last step. So that's how you set up the steps. And then the auto cycle viewer is where you control the program. The cycle preset is how many total cycles we're going to complete. The completed cycle, that will count up from 0 to the preset value and then shut off when it reaches the preset. Average cycle time is the amount of time for that complete cycle. So that complete set of operations that we define in the steps editor. So this is a percent scale, percent complete of the whole test. So I stopped this one at 374 out of 500, so it's roughly 75% complete. Inputs, this is just going to be 1. We're going to get rid of the others, and that's whenever that sees a continuity, that number 1 input will turn green. So it's just an indicator. And statistics, as it marches along on a test, it'll populate all this with maximum velocities, if it failed, how many passes on the inputs, all that stuff. Before you do a test, reset. So it resets the completed cycles and resets all of that. And that's it. So I think we're ready to start. I'm going to turn this back on because it always turns off on me. And we're going to set that to grams. I hope it stays on for me. And to do a test, you switch it from manual to automatic. I don't think we talked about this, but you always return home, so that moves it back to that 0 position. Start single cycle. It'll take your test and just run one, I guess each step for 1 cycle. In this case, it's just pressing and returning. And a dry cycle, if you have multiple steps, it will do each step and then stop, and it won't do multiple cycles. Dry cycle does the same thing, except instead of a full press, it just moves down a little bit just to indicate that it's going to press at that location. You may want to do that if you don't want to actually hit your button that you have set up yet, but you want an indication of how the machine's going to operate, so you can hit that. We're ready. So automatic, always return home before you start a test. When I hit start cycle, it's going to start cycling. Everything's ready. So it's pressing up and down, and it's going quick enough that my scale does not update very quickly. So if I want to see, if I want to slow this thing down, I can. So dwell time, I'm going to change that to 2,000 milliseconds. You can hear it stop. See, it's actually present at 300 grams. The scale is slow, not the actuator. So that delay in the readout is from the scale, but it's right at within 1%. So we calibrated that really well. So we're at 52 cycles. It's going to stop at 500. I can pause this at it end, and it'll pause in the upward position at the end of the cycle. Of course, it's not pressing, so it's pausing. We can inspect our sample, whatever we want to do, hit start again, and it'll continue again. Okay, so what else? So yeah, I can change that back to say 50 milliseconds. You can go as low as 5 actually. So that's You can't do 0, but you can do 5 millisecond dwell time, which is almost 0. The scale's not keeping up. And you can speed this up by minimizing the distance between the finger and the part, and it'll go a little quicker. Currently, it's doing 0.7 to, well, it's getting quicker because I changed the speed. But so that's the average cycle time for this test. And since I sped it up, it's going down quicker. I'm just going to hit reset. Oh, I can't do that. Pause, reset. I have to pause the reset. So now, yeah, see, I had some other data in there from the other cycles that was averaging that real high. So we're going about 0.39 seconds per cycle, which is not quite 3 cycles per second. So I could minimize that distance, and I could change velocities as well. Instead of 200, I can change that. So a standard test like this, you can get right around 3 cycles per second. And if you increase your load, you can actually increase the cycle. Or if you increase your force, you can increase the velocity and have better control over that too. So I think I've mentioned everything as far as the screens and how to control everything. The only other thing I want to mention is you see we have that's our standard finger probe, the FP1 style, kind of the natural white type silicone. So we have 2 different types, 2 different styles of finger probes. The FP1 that you see on the left, the FP2 on the right. These are ASTM designated probes as far as they control the dimensions and the durometer. The difference between the 2 is one's male, one's female, and the female has a smaller diameter. The other difference you'll see is the black ones are conductive. So there's actual conductive material in there. A little bit harder. They store a value of 50 rather than 45 on average. And but if you have a capacitive touchscreen, that's what you need. And you should be able to just connect it to this guy. And this is grounded all the way through the system and through the controller to your ground plug. So, oh, and the other thing, you see we have some fabric wrapped around there. That's to duplicate or replicate the abrasion qualities of a human finger. That's what this is, our standard fabric. That's offered on our website. It comes in a roll. You cut it up as you need it. And if you have a capacitive, the black one's there, you want to use a conductive fabric. The abrasion quality is a little different, close as we can though, but that's conductive fabric, and it has some silver yarn in there to create the conductivity. All that's offered on our website, just like you see it there. And I think that's everything that I wanted to mention. So sorry for the long video, but I wanted to explain everything that all the operations of the machine. So if you have any questions, go to our website, check out everything that we have and other products that we offer. And we have a contact us page. Go on there and send us a message, and we will answer any questions you have.